Today, on how it's made. Ice cream cones. Tent trailers. Shoe polish. And pliers. The ice cream cone is the original edible container. Invented over a century ago, it adds crunch to the melt-in-your-mouth taste of ice cream. And it's one container that doesn't end up in the trash can. So you could say it adds a bit of virtue to the guilty pleasure of the double scoop. The first ice cream cones were rolled waffles, and today's cones are simply modern versions of that. Waffle cone batter starts with a lot of dark brown sugar. Caramel coloring is added, along with some secret flavoring ingredients. Water is piped into the blender. It's ice cold to keep the batter from getting too sticky. A computer controls the addition of flour from a tank on the floor above. Vegetable oil is added as a giant beater mixes all the ingredients. The batter then flows out of the blender and into a refrigerated tank. An agitating blade keeps the blend at the consistency of pancake batter. Next, nozzles deposit batter onto baking plates that look like moving waffle irons. Top plates flip down and the baking plates roll through a glass-heated oven for a quick bake. The top plates lift up, revealing the cooked waffle patties. Automated arms help transfer the patties to rolling tools. The tools grab the patties and twist them into cones. The cones fall down a chute and ride an open elevator up and down to cool and harden. The waffle cones slide down another chute and move into lanes on a conveyor. Automated fingers help guide them into paper jackets. A computer with a camera eye counts the cones and sends a message to a machine that stacks them in the right increments. Here, a technician activates a device that pushes on a ball inside a cone to test the cone's breaking point. Looks like this waffle cone can hold up to some heavy licking. Over in the sugar cone department, the baking plate system is designed differently. It makes patties that are fan-shaped and have a flat edge. This shape, along with a firmer batter, means sugar cones are stronger than waffle cones, so they're a more popular choice for hard ice cream. Packers stack the cones in styrofoam trays. Then the packages travel through a curtain of high-density polyethylene film. A heated sealer finishes the wrapping job. An X-ray machine sends information about the contents to a computer that counts the cones and alerts inspectors to any problems. Next, automated arms pick up cartons and open them so the packs of cones can be inserted. But there's still one more cone variety in the works: colorful cake cones. Cake cones are less sugary than other varieties and have a more cake-like texture. Batter is pumped into upright molds. Cake cones are shaped differently from waffle and sugar cones because they have flat rather than pointed bottoms. Metal cores plunge into the molds to complete the shape. This action also enhances the cake cone's flaky texture. The cones are baked as they pass by a gauntlet of gas heaters. Then it's down a chute and off to the packaging station. Unlike the other cones, cake cones come out flaky and crispy without a cooling down period. A mechanical arm picks up paper sleeves and drops them in front of the cones. These cones are now on their way to an ice cream stand near you, where they'll be used to scoop up ice cream lickety-split. When we return, building a tent trailer from the bottom up. Tent trailers allow you to travel without reservations. Who needs a hotel if you can park the pop-up? Besides, you don't get fresh air and campfires at a hotel. Tent trailers have been around since the early part of the 20th century, and you could describe them as an overnight success. Today's tent trailers are equipped with modern conveniences that would make anyone a happy camper. Workers begin production by welding tubular steel components together to establish a solid framework. Once it's painted, plumbed, and partially wired, wheels are bolted into place. The water storage tank goes in next. Then, aircraft-grade steel cables are strung from corner posts to a central bar. This bar is called a whiffle tree. Cranking up the whiffle tree will cause the cables to lift the corner posts, raising the trailer's roof. The trailer is wheeled to the next station, where workers lower a vinyl-covered wooden floor onto the chassis and secure it with screws. Then, they connect a cluster of wires to those already installed on the chassis to run things like kitchen appliances and stereos. The interior front wall is riveted to steel bulkheads and the trailer chassis. More wiring is threaded through the bulkheads to the trailer's side lights, and then the exterior panel is installed. Workers slide the roadside panel over the lift posts and secure it. The curbside exterior panels come in two pieces to create a space for the trailer door. Corner molding completes this assembly. Next, workers move inside and install the framework for some bench seating. They install the lower cabinetry for the kitchenette, then join it to the upper cabinet with a long metal hinge for easy pivoting. A mini fridge is inserted in the lower cabinetry, and this folding kitchenette is complete. This is the pull-out platform for one of the mattresses. It slides into channels in the exterior walls. But there's a lot more work to do before anyone can take a nap. The trailer's tent is made out of water-resistant fabric. The 5 sections are sewn separately, then zipped together at an inspection station. Inspectors scrutinize every seam for flaws. Once the tent passes inspection, it's fit onto the trailer one section at a time. Now it's time for a little roofing. The trailer's roof is made by sandwiching together many materials, and that takes a lot of industrial adhesive. The glue is rolled onto these plywood slats. These foam insulation boards also get a generous coating. Workers place the glued foam onto the roof's fiberglass outer skin. They position the wooden slats along the perimeter and add bands of metal for more reinforcement. The final layer is vinyl-coated plywood. It will be the ceiling of the trailer. A large roller compresses the glued layers together. After grooves and notches have been cut into the roof, it's wired up and 12-volt interior lights are installed in the ceiling. Trim is added to the roof's edges along with a gasket to keep it watertight. The roof's flaps are folded in a tray-like configuration and the corners are capped. Workers are now ready to raise the roof and install the tent. The assembly is inserted into grooves in the trailer ceiling using a pneumatic hammer. This tent trailer is now ready to pop up anywhere. It can accommodate a small family and is equipped to feed them outdoors or inside. It even comes with a screen door because you never know when adventure will come knocking. Coming up, a production line you can really take a shine to. Mud and scuffing have long been the bane of shoes and boots. In medieval times, wax was used to soften and waterproof leather footwear, but it had a dull finish. It wasn't until the early 20th century, with the invention of shoe polish, that footwear really started to shine. All it takes is a bit of polish and a lot of elbow grease. A vigorous brushing can enhance the job and help transform shoes from drab to fab. Shoe polish starts with mineral spirit solvent and different combinations of carnauba wax. The waxes go into a melter where they're heated to 260 degrees. The mixture cooks for 15 minutes while beaters keep everything blended together. This is dye fluid in a deep black shade. In another tank, the dye fluid and waxes are added to the solvent blend. Agitators mix it for 3 minutes. Tin container bottoms tumble down a chute and up a magnetic conveyor belt. A worker flips the tins right side up, then pushes them onto another conveyor. Once they're lined up, they're ready to be filled. Automated arms space the tins as they arrive at the filling head. The filling heads inject hot liquid shoe polish into the tins. The polish is precisely doled out so there's no spillover. The polish now needs to solidify, so the tins travel through a cooling tunnel. When they emerge, the polish is a thick paste. Workers perform a breaking strength test to be sure the final product has the right consistency. The polish-filled tins now funnel onto a conveyor that merges with a lid feeder. The feeder lowers the lids onto the tins. A compression wheel presses the lids in place with just the right amount of force. And this polish is now ready to shine. There's a different packaging system for liquid shoe polish. A blow molding machine forces hot air into plastic to form containers. Then, the mechanized rack holding the containers rotates and places the newly formed bottles on another conveyor. It moves them under a flame, which melts the rough edges. Revolving conveyors move under filling heads, which pump in liquid polish. Workers insert valves into applicators. Then, this machine press-fits the applicators onto the polish-filled containers. Using hydraulic pressure, another machine snaps clear domes onto the applicators. rollers affix labels onto both sides of the bottles. The bottles then move through an inspection station. A mirror helps workers scrutinize the labeling job. A technician now takes a preliminary reading of the gloss on some leather. He applies some paste polish and rubs it in with a horsehair brush. He takes another reading, and the gloss on this leather has increased by a factor of 2, which means this polish passes muster and is ready to add some high luster to your footwear. When we return, Plier production, the gripping truth. Pliers date back to around 2000 BC. Ancient drawings show Greek gods with pliers at the forge. Today, forgers still make pliers, but these days they use automated tools to shape the metal. Without them, a lot of electricians, plumbers, and mechanics would be out of a job. Pliers have 3 basic parts: handles, a rivet, and jaws. All the parts are made from steel that metal workers forge into shape. First, a powerful electric furnace heats the steel red hot in just a few seconds. Then, a metal worker sets one sizzling rod at a time on a forming die. A massive die forger hammers the rod against the die with tons of force. It takes up to 4 strikes on separate impressions for the rod to acquire the die's shape. Then the forging is placed onto a press that trims off any excess steel. Two forged rods are needed to make one pair of pliers. This pair will be for gripping, so the next step is to machine the teeth into the jaws. Workers set the plier halves into the broaching machine. Its tiny cutters, dozens of them, shave away steel under a shower of lubricant. When the cutters pull away, the jaw of each plier half now has a nice set of teeth. The factory must heat treat the steel to harden it, a process called austempering. The plier halves travel through a gas-fired furnace for about 2 hours at a blazing 1500 degrees. Then, the steel is dunked in salt water to cool rapidly and evenly. The teeth on these pliers will have to take a lot of abuse, so they get a laser heat treatment to make them even harder and more durable. Now the pliers are ready for assembly. For gripping pliers, a worker inserts a single piece rivet and joins the 2 halves. He then sets the joint onto a machine that spins at high speed, generating the force and friction needed to set the rivet. Cutting pliers are also held together with a rivet, but the setting process is different. The parts go into a press that applies both heat and pressure to secure the rivet firmly. Next, workers insert the cutting pliers between 2 stone grinding wheels. Again, lubricant prevents the steel from overheating as the wheels wear down the rivet until it lies flush with the plier surface. The cutting pliers go into a gas oven for another 2 hours of heat treating, a process called mar tempering. When they come out, they cool in an oil solution, rather than the salt solution that cools the gripping pliers. Steel is a finicky material, so it's critical to manage the heat treating process meticulously. Otherwise, the metal will be substandard. After heat treating, the pliers go into a bath of rust inhibitor that helps protect the steel from corrosion and lubricates the riveted joints. A robotic arm runs one pair of pliers at a time against a grinding belt, polishing all surfaces except the handles for a sleek finish. Then a laser engraves the company logo and product number. Automated bars now lower hundreds of pliers handle deep into a tank containing liquid vinyl. No messy drips here. Before dipping, the factory heats the pliers to help this coating stick to the steel. Next, the pliers go into an oven. The heat hardens the protective coating, cushioning the handles so they're easier on the hands. Whatever their shape or size, pliers are a toolbox essential for anyone looking to ply their trade. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.